Hi, welcome to another video on control system. In this video, we talk about all about the stability of control system. So we basically discuss there are different ways of finding the stability of system. So let us try to find out okay, in what is the difference between each different technique or different ways of finding the control system. What is similarity of the stuff? Okay, for that we should know transfer function, poles and zeros. What is stability? How do we write root array? What is root locus, Bode plot, and Nyquist? Of course, these are the prerequisites. Fine. Let us start the discussion. Okay. Uh, in a control system, uh, we know that there is something like called as frequency response of the system, which is typically used to find the stability of the system. And we also have another technique where we call as a root locus. It's again to find the stability of the system. This is root locus of the system. So now the frequency response has got two different plots. One is called as Bode plot, and the other one is Nyquist plot. This Nyquist criteria involves writing the polar plot of a system to find the stability of the system. So by this time we already know what is stability of system. A system which will give a bounded output is called as, for a given bounded input is called as a stable system. Suppose if this is the input and this is the output, if you have a system here, if the input is bounded, if the resulting output is also bounded, then we say system is stable. If the output goes unbounded, then we say system is unstable. If the output is oscillatory, then we say the system is oscillatory or marginally stable system. So now, before we actually go into relative system of those things, let us look at some okay, how do we write magnitude and phase of uh, uh, different poles and zeros at different point. So because that's what is this frequency response is all about. If I have it as a pole at 10, so we always replace s by j omega. So this is j omega plus 10. So this can be written as 1 over 10 plus j omega. Of course, we know the general form of 1 over a plus jb, which has got magnitude as well as phase of it. So the magnitude of this is given by under root of a square plus b square. The phase of that again in the denominator is given by tan inverse of quotient of imaginary by quotient of the real value. So this is b by a, and its value, the actual value happens to be under root of a square plus b square, and of course this is minus tan inverse of this is the phase b by a. Similarly for this, so what is the magnitude of this one? Suppose if I want to know the magnitude of this, so this happens to be 1 over root of 10 square plus omega square, and the phase is minus tan inverse of omega by 10, omega by 10. Again, similarly, if I want to write what is s plus 4 magnitude and phase, I'll replace this by j omega plus 4 is equal to the magnitude part is omega square plus 4 square. The phase part is tan inverse of omega by 4, omega by 4. So this is the magnitude, this is the phase part of it. Now suppose you have a term, something like 3 plus j2, and suppose if it is 3 plus j2, where is this located? Suppose if you identify the first, second, third, the fourth quadrant of the graph. So this is magnitude 2 and here it is plus j3. The coordinate of these two will meet here. Okay, this is that point. So this is a point. If I want to know the magnitude of this, so the magnitude of this is nothing but, if I want to know the magnitude, so magnitude is nothing but under root of 3 square plus 2 square. So that's what is the magnitude of this one. And what is the phase angle? The phase angle is nothing but this angle. So this is the phase angle, which is nothing but tan inverse of opposite. Sorry, this is actually this is 3, is 2. For tan inverse of so what you have is tan inverse of b by a. B is nothing but the quotient of imaginary, which is nothing but this opposite. This is the angle theta. So this is 2 by 3. This is 2 by 3. So the magnitude of this is under root of 2 square plus 3 square. The phase angle is tan inverse of 2 by 3, because 3 is the real value or the adjacent, and 2 is the magnitude of the opposite side. So that's what is this. Suppose if I want to represent, or if I want to find the magnitude on phase of 3 minus j2, if it is this, so I know that it is it's a real value 3 and it's a negative imagined value, which is minus j2. The point is this. So I want to know what is this magnitude, and I want to know this phase. So now if you have something like this term, so it is nothing but magnitude is 3 square plus 2 square, because this magnitude, irrespective whether it is positive or negative, it is under root of 3 square plus 3 square plus 2 square. Now the phase angle is minus of, because we know that this is how we measure a positive angle, and the clockwise direction it is always negative angle. So it is minus tan inverse of what is imaginary. Imaginary quotient is 2 by 3. So now if you have a term something like 3 minus j2, its magnitude is root of 3 square plus 2 square, and its phase is tan inverse of so on. Suppose if you have a term something like this, so let us assume that I have a term which is uh, this is j4 minus 2, j4 minus 2. So then if you can see real value is negative, and the imagined value is actually plus j4. The intersection of this is somewhere here. Now I want to know the magnitude. So what is this magnitude? So magnitude is given by, so this is it is a magnitude of hypotenuse is given by square root of the adjacent square plus the opposite square. So that is 4 square. So this is a magnitude. About the phase, I want to know what is this phase. This is the phase angle. So phase angle phi is now written as, so now this can be now written as, this is overall 180 degree. This is 180 degree, and it is difficult to know this angle directly. So what we'll do, we know this 180 degree, so it is 180 degree. I know this angle. So how much is this angle? This angle is tan inverse of, so what is the opposite? Opposite is 4, the adjacent is 2. So it is 180 degree minus this angle, so it is minus. So if you have the real part as negative and the imaginary part as positive, it is, this is the angle. This is the magnitude and phase angle. And of course you can also think of both being negative. So it's like, okay, minus 2 minus of j4. So where does that minus 2 minus of j4 come? So this is minus 2, this is minus j4. Their intersection will happen here. So this is a point. If you want to know the magnitude, so what is the magnitude of this? It is under root of 2 square plus 4 square. But how about the phase? Phase is nothing but, so phase is nothing but, can I do this angle? Is this how much? This is minus 180 degree. Can you see you are going in the direction opposite to the normal? This is positive, and this is negative. Negative. This is minus 180 degree. I want to know this angle. So it is minus 180 degree plus of this phi. So this phi is nothing but tan inverse of what is opposite? Opposite is 4, the adjacent is 2. So it is the phi for this minus 2 minus j4 is minus 180 degree plus of tan inverse of 4 by 4 by 2. Correct? I'm just trying to locate the points in all the quadrants and trying to find out what is the phase. Suppose assume that I have a term something like a square plus 4s plus 10. If I want to find the phase of this, phase and magnitude, so let us substitute s by j omega. When I substitute s by j omega, you see it is now j omega square plus 4 into j omega plus 10. So then this j omega square is minus omega. It's like okay, j square into omega square. J square is minus 1 plus of j 4 omega plus 10. Group the real parts. It is 10 minus omega square and plus j 4 omega. So this is the term what you have. Because now the omega ranges from 0 to infinity. Omega ranges from 0 to infinity. So now as long as okay, what is the magnitude of this one? So magnitude of this is nothing but it's like a plus jb. So we know that if it is a plus jb, so the magnitude is under root of a square plus b square. So now what is in place of what you have? You have 10 minus omega square as a, that square. So it is a square plus b square. B square is 4 omega whole square. Okay. So the magnitude of this would be root of 10 minus omega. Of course, you know how I wrote this. So just group this because these two are real parts and this is the imaginary part. So this is the imaginary part. So I'm grouping it and under root of real square plus uh, coefficient of imaginary square. And then what's the phase angle? Phase angle, see now, because omega is ranging from greater than 0 to less than infinity, this quantity can be positive as well as negative. So when does this quantities this quantity can be either positive, either negative, or it can be zero also, So when this is positive, so this 10 minus omega square is positive as long as omega square is less than 10. When omega square is less than 10, it is positive. So this 10 minus omega square is positive as long as omega square is less than 10 or omega is less than root of 10. So when omega is less than root 10, can I write the phase of this as tan inverse of 4 omega by 10 minus omega square for all values of omega less than or equal to 0 to less than or equal to root 10. So this is what is, because this is positive. If it is positive, then this is positive, then it's like having a pole in the first quadrant. If a point is there in the first quadrant, then the phase is inverse of opposite by the adjacent, that is imaginary by the real. So since the imaginary quantity is 4 omega, I wrote it as 4 omega. The real part is 10 minus omega square. It is 10 minus omega square. This is when, as long as this is positive as well as 0. When it is 0, sorry, when it is root 10, when omega is root 10, so this comes out to be 0. When it becomes 0, we know that it will actually come over here. So this will only imaginary term is there. So real term is 0. It will come over here. The angle is 90 degree. The angle will become 90 degree when omega is equal to root 10. When omega is equal to root 10. So what happens if the value of omega is more than root 10? For values of omega greater than root 10, this 10 minus omega square plus j4 omega, this quantity will become negative. So once it becomes negative, so you are moving on to the second quadrant. The The moment when you move whenever your point moves to second quadrant, the phase angle is, now I will slightly change this. So what will be the phase angle? Phase angle is, suppose it is this, it is 180 degree. It is 180 degree minus tan inverse of, because I have to take this as now positive term. So how do I make this positive term? It is omega square minus 10. So it is 4 omega by omega square minus 10. Because this should not be no more again a negative value. So they should become positive value, because whatever negative component was there, you just modified it by taking 180 degree. So this is the phase angle for values of omega greater than root 10. So for this particular quantity, which is nothing but a square plus 4s plus 10, a square plus 4s plus 10, got two phase equations. So one of the phase equation is, I'm just simply writing whether it is polar zero, it is immaterial. I'm just writing for this term. It is, for the first term, the phase is tan inverse of 4 omega by 10 minus omega square for all values of omega between 0 and root 10. The same phi is 180 degree minus tan inverse of 4 omega, 4 omega by omega square minus 10 for all values of omega greater than root 10. Suppose if the value of omega tends to infinity, which term I have to take? I have to take for all values of omega greater than root 10, I have to use this equation. Assume that if omega tends to infinity, so this will be 180 degree minus of tan inverse of, it's like 4 infinity by infinity square minus 10. So since you can see there is a 4 infinity in the infinity square, it's 4 infinity in the infinity square. Since the denominator is moving faster, so then this entire value tends to 0. So tan inverse of 0 is 0. So this is equal to minus 180 degree, plus 180 degree. So whatever 180 degree you have, that is 180 degree. When omega tends to infinity, this quantity becomes larger compared to the numerator, then the entire value tends to 0. And tan inverse of 0 is 0. So you have this only 180 degree. Okay. So now let us take, if you have a term which is like 1 over s. If you have 1 over s, then what is its phase and magnitude? Just simply replace it by j omega. 1 over j omega. So can I write it as 1 over 0 plus j omega? So then what is the magnitude? Magnitude is 0 square plus omega square. So since it is root of 0 square plus omega square, this is 0. So can I write it as 1 over omega? So this is a magnitude. How about the phase? So phase is tan inverse of j omega, of course, omega by 0. So omega by 0 is, it is tan inverse of infinity. Tan inverse of infinity is, if you can see, this is all in the denominator, so it will become negative. So tan inverse of infinity is actually 90 degree. So this will become minus 90 degree. So 1 over s will have a magnitude of 1 over omega. It won't have a phase of minus 90 degree. How about term s? S can be now replaced by j omega. So it is now again 0 plus j omega. What is the magnitude? Magnitude is root of omega square, which is omega. What is the phase? Phase is tan inverse of omega by 0. It is plus 90 degree. So a 0 at origin will have plus 90 degree as the phase. The magnitude is omega. 1 over s, a pole at origin will going to have a phase of minus 90 degree. You see this is minus 90 degree for all the frequencies. It is independent of frequency. Suppose you have a term 50. Suppose we have a 100. So how do I write 100? Can I write 100 plus j0? What is the magnitude? It is 100 square plus 0 square. So what is 100? This will become 0. Square and root will go off and it will end up in 100. So magnitude of 100 is 100 only. So how about the phase? It is tan inverse of 0 by 100. Excuse me. since tan inverse of 0 by 100 is tan inverse of 0, that is equal to 0 degree. So this will always have a magnitude 100, phase angle 0 degree. So that's why we never consider the phase angle for a constant term. Suppose if you have minus 50 as a term, so then what is this magnitude? Because now minus 50 you're locating it here, you're locating it here, so this is 50 over here. So then it will going to have a phase of minus 180 degree, minus 180 degree. So either minus 180 degree or it can be plus 180 degree. So that's why we write minus 50 can be written as 50 at an angle plus or minus 180 degree, plus or minus 180 degree. Because if you are measuring from here, it is plus 90. If you are measuring from here, it is minus 180 degree. Plus 180 degree, this is minus 1. That's why we write it as plus or minus 180 degree. Okay, these are all very basic prerequisites. Okay. Even then it is prerequisite, but it is a must. Let us start uh, doing problems one by one. So let me just take the problem which is given over here. So let me just take the first problem, which is GFS into HFS, which is given by 10 by S into 1 plus 0.1 S and 1 plus 0.04 S. This is nothing but this is the time constant form. So I want to find what is the magnitude. So magnitude, if you want to put it in dB, so we just write it as 20 log of 10, and since it is 1 over s, it is minus 20 log of omega. And let me also say how do I find uh, magnitude of certain value in terms of dBs. Let me just put it here. If I have 1 over s plus, plus 2, so can I write it as 2 plus j omega? So then how do I write the magnitude in terms of dBs? So we know that magnitude is given by 1 over root of 2 square plus omega square. This is the magnitude. And if I want to put this in dBs, so it is 20 log of this 1 over under root of 2 square plus omega square. This is what is this. So I know that log of 1 over a is nothing but minus log of a, minus log of a. So now I have similar situation here. So what I have, I also know that log of uh, a square or an is nothing but let me just write it as log of an is nothing but n into log of a, n into log of this. N can be half, 2, 3, whatever. So if it is log of a to the power of half, then it is half log of a, log of a, right? So now we have similar type of situation here. Since you have 1 over something, can I write this as minus 20 log of under root of 2 square plus omega square? I can write it so. Since what is this? Can I write it as minus 20 log of 2 square plus omega square to the power half? So this half, I bring it down. It is minus half into 20 log of 2 square plus omega square. So can I now ultimately write this as minus 10 log omega square plus 2 square. So a quantity which is s plus 2 can be written as minus 10 log omega square plus 2 square. Similarly, if you have a term something like this 1 over s, suppose if I have a term 1 over s, so in terms of dB, how do I write? So it is 20 log of 1 over, okay, it is 1 over omega because j will go off because of the magnitude. So can I write it as minus 20 log omega? because 1 over omega is there, log of 1 over omega is nothing but minus log omega. So this 20 is there, so this is to indicate that this is in decibels. Fine. Okay, with these prerequisites, so this is what is 1 over s is 20 log of 10, sorry, 10 is 20 log 10, and 1 over s is 20 log omega, and this quantity, and I now write it as minus 10 log of 1 square plus 0.1 omega whole square, because 1 square is 1 only. Then last term minus 10 log 1 plus 0.04 omega whole square, correct? And this is in terms of dBs. I can also specify this in terms of values as it is. So it is magnitude is nothing but 10 divided by omega into, what is this? Is it not 1 plus 0.1 omega whole square? Can I also write the next term as 1 plus point not 4 omega whole square? So this is the value. These are the magnitude. But the phase, because you have the phase of 10 is not considered because it will not contribute any phase. How about the phase of this? So this is minus 90 degree. How about the phase of this? It is a pole, that's why it is tan inverse of 0.1 omega by 1. So since in the denominator is 1, you can simply write as minus tan inverse of 0.1 omega minus tan inverse of 0.04 omega. Now we know that we need to find omega GC and omega PC. So what is omega GC? It is that omega where the magnitude is 0 dB if it is in terms of dBs, or magnitude is 1 if the magnitude is in absolute value. So what is this magnitude? It is GFS into HFS magnitude. So this is GH magnitude. If it is in dBs, it is 0 dB. So now how to get this value? So you use this equation, equate it to 0, and you'll get omega GC. You equate this to 1, you'll get omega GC. So both omega GC will be same. So let me use two calculators, one for dB1 and other is for the magnitude as it is. So let me just type the dB wala. So it is now 0 alpha equals, so hope it is, now let me make the orientation such that it is visible. Is 10 0. I'm just going to type it here. So it is 20 log 10 minus 20 log alpha a minus 10 log, open the parenthesis, 1 plus, open the parenthesis, 0.1 alpha a, close the parenthesis, square, close. I did the exactly same thing. You can just go back and see here. What I did, it is 10 log, open the parenthesis, 1 plus 0.1 omega, omega is alpha a square, minus 10 log, open the parenthesis, 1 plus, open the parenthesis, 0.04 alpha a, close, square, close. Now let me do shift calculate, it will give me omega GC value. So omega GC is 7.61. You can see now omega GC, when I equate it to 0, dB is now 7.61 radian per second. Let me use this and equate it to 1. When I'm equating this to 1, is it not equating this 10 to the denominator? I can do the same thing here. You can see now. So I will make this 10 alpha equals, so what is this? Alpha a multiplied by, open the parenthesis, square root, open the parenthesis, 1 plus, open the parenthesis, 0.1 into alpha a, close the parenthesis, square, close the parenthesis again. Okay, 1, 2, 3, 1, 2. Let me just again close it. Multiplied by, open the parenthesis, square root, open the parenthesis, 1 plus, open the parenthesis, 0.04 alpha a, close, square, close, 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 shift cal. Now there is some syntax error. I think I just put one extra. Okay, now let me do shift cal. Now it should give me exactly 7.61. Can you see it gave me 7.61 only? 7.61. So what is this we are trying to find? We are using either this equation or this equation to get omega GC. What is omega GC? Omega GC is the frequency at which magnitude of the entire transfer function becomes 1. So which is 7.61. What I'll do, I will retain this magnitude equation dBs as it is. Let me come out here and try to feed this equation, find omega PC. So it is that omega where the phase becomes minus 180 degree. So what I'll do now, it is minus 180 degree alpha equals, so I'm equating this to minus 180 degree. Equate this to minus 180 degree, try to find what is omega at which this equation is minus 180. Minus 180 degree equals minus 90 minus tan inverse of minus tan inverse of 0.1 alpha a minus tan inverse of 0.04 alpha a. Shift L. How much is omega PC? Omega PC is coming out to be, so now this is omega PC, which is 15.81 radian per second. It is 15.81 radian per second. So now we have omega GC, we have omega GC, and we have omega PC. So having this omega GC and omega PC, we can find what is gain and phase margin. Phase margin. Phase margin of the system. You see, we're not at all plotting the system or the Bode plot or the Nyquist plot, but still we are trying to find out what is gain margin or the phase margin. Because now, how do I find gain margin? So gain margin is nothing but it's 1 over the magnitude at omega equal to omega EC. If it is in absolute value, so gain margin is nothing but negative of the magnitude of omega equal to omega PC if it is measured in dB. So since I have the dB equation here, what I'll do, so this is my equation. You can see here I have equated this to 0 dB and 0 alpha equals, can you see I'm having the same equation being fed in. What I'll do, I will remove this. So I will just remove that 0 as well as alpha equals. So I have removed this. Remove this 0 and then alpha equals. Now I will calculate the value at omega PC. Omega PC is how much? 15 point. So I just simply pressed calculate. Now it is asking for a question mark. Now I will edit 15.81. So what is this? What is the magnitude of, what is the value of this with the value of omega is 15.81. So I'm getting it as, since it is in dBs, I'm getting the dB as, so this is minus of minus, it is minus 10.87 dB. So what is this magnitude? This magnitude is how much? So shall I write it as 10.87 dB is the gain margin. So what is this 10.87? So I can find the magnitude of this one. So what is 10.87 dB in actual value corresponds to? It corresponds to 10 to the power of uh, 10.87 by 20. How much is this? So it is 10 to the power of 10 to the power of 10.87 by 20. How much is that? So that have, sorry, I didn't find this bestowed. It is 10.87 divided by 20. Can you see it is now 3.49? It is 3.49. So gain margin is now, so of course this is 1 over 3.49. So gain margin now is equal to 3.49. 3.49. So it is not this. Okay, what is this? 10 to the power of 10 to the power of minus 10.87 by 20 would be, this is actually 1 over 0.286. 1 over 0.286 is 3.49. So magnitude at omega is equal to omega PC would be 0.287. Then gain margin is 1 over that. So what is 1 over this? So it is 3.49. So we obtained the gain margin as 3.49, or in dBs it is 10.87 dBs. So this is gain margin. So what is phase margin? Phase margin is nothing but 180 degree plus the phase at omega DC. So we know that I have this as my phase equation. In this phase equation, I have to find what is the phase at omega equal to omega DC. So what I'll do, now I have this equation. So I have equated this to minus 180 degree to find omega DC. I will take out this minus 180. You can see I'm just taking out this minus 180. Here I have removed that minus 180. Now I will calculate at 7.7 because omega GC is 7.61. So what is the phase? Phase is minus 144 degree. So it is minus 144.2 degrees. So what is phase margin? It is 180 degree plus of minus 144.2 degrees. So which is plus of 180. Can you see it is 35.79 degrees? This is phase. What is gain margin? Gain margin is 3.4. So that's what I have here. See here, this is I have calculated. So this is obtained from MATLAB, which exactly tallies with whatever that we have got here. Density is 3.61 omega GC, omega BC is 15.81. Can you see what is the gain margin is 3.5? The phase margin is 30. Where is that? 35.79. Can you see this? So it is basically you have to feed the equation, make this alpha equals to minus 180 degree will give you omega PC, and alpha equal to 0 dB or 0 will give you omega GC, or equating this to this will give you omega GC. So this is the magnitude equation in absolute value, this is in dBs. So this is how we can do the gain margin and phase margin calculation. Okay, let us try to understand what is this gain margin of 3.49 means. So is the system stable? Yes. Maybe before we talk about the stability, of course, we should be in a position to plot the root locus of a given transfer function so that it will give an idea how does the system stability looks like. So now can we just write this as the pole position? This is at minus 10, and where is this 0.04 is actually 0.04 is 25. So this is at minus 25. So now if I try to plot the root locus of this, it actually goes this way. these two will break somewhere here, and then finally it goes like this. You see, this is how the expected root locus is, and this value 10 is the what is this? This is the system gain. So what is the root locus gain of this? So what I'll do here is uh, I will multiply and divide it by I will multiply and divide it by uh, so I have to get this in the form of uh, so what do you have now? So it is 10 by s into 1 plus 0.1 years, and it is 1 plus 0.04 years. So what I'll do, I will multiply this by divide this by 10. I will multiply this by 25 and divide this by 25. Any change? No change. So what I'll do, so what will happen to this? If I multiply 10 to this, so will it not become, so 10 plus yes, correct? Will it become 10 plus yes? And will it become, what does this will become? So if I multiply this with this, will it actually become 25 plus yes? What does this will become? Will it actually become 10 into 10 into 25? Is it now 2500? So this is my GFS into HFS. Now these two are same now. So these two are same. So what is this? What is this? Both are trans function of the same system, but this is now represented in the form of full zero form. Full zero form. This is in the form of time constant form. In the form of time constant. You can see it is 1 plus s tau. It is 1 plus s tau. Now it is s plus 10, s plus 25. So you have poles at origin plus 10 and sorry minus 10 and minus 25. That's what I've written here. Since the value of k is 2500 root locus gain, so what it says is system is stable. System is stable. So you got a gain margin of 3 point how much? 3.49. A gain margin of 3.49 means the existing system gain. If it is multiplied by 3.49, so then this will become 34.9. For a system gain of 34.9, the system will be oscillatory. The system will be oscillatory. Gain margin means you can make a system oscillatory if the existing system gain, if it is multiplied by gain margin time. So 10 into gain margin will make the system, of course you'll get, in this case it is 34.9. If it is 34.9, then with 34.9 as a system gain, the system will be oscillating. So that's what is the meaning of this gain margin of 3.49. Meaning that system has a margin increase in the gain by 3.49 times, the system will be still stable. If it is increased exactly to 3.49, then system is oscillatory. If the gain is increased beyond 3.49, then system is unstable. Because as you can see here, so if it is 3.49, the roots will come on to matched axis. If it is less than 3.49, you can see all the roots are there on the left hand side. If you give it more than 3.49 with the existing gain, if the multiplication factor is 3.5 or 3.51, then poles come on to right hand side, system will become unstable. Fine. Okay, let us take up the next example. So let me take this. So I'm taking a different example where you have something like this. It is GFS into HFS is equal to 8 into S plus 1 by S into S plus 10 S plus So if I can write the pole zero plot of this, let us predict the system stability and then try to realize that. So it is this here, it is minus 10 and it is minus 50 and you have a 0 at minus 1. So now can I write the root locus as somewhere here? So this is 1 and they actually go here like this. So asymptote will come somewhere here, somewhere here. So it is minus 10 minus 50 plus of 1 by 2. So it is around somewhere 30. It will come somewhere here. So now this is what is expected. Now system is absolutely stable. So what is system means absolutely stable? So if you increase the gain by whatever amount, system will never become oscillator because it's never going closer to the imaginary axis. So I am expecting a gain margin of infinite dBs. Infinite dBs. So if you can predict like that, then it is very easy. You will not do any mistake. Let us try to find the magnitude. So what is magnitude equation? Can you see now it is 20 log of 80 plus 10 log of 1 plus omega square minus 20 log of omega minus 10 log of omega square plus 10 square minus 10 log of omega square plus 50 square. Over the phase, I will not write the magnitude equation, that is with dBs. So what is phase angle? Phase angle is minus 90 degree plus of tan inverse of omega by 1 minus tan inverse of omega by 10. This is minus tan inverse of omega by 50. So you may be wondering why I'm writing a magnitude equation without bringing this into the time constant form. It is not necessary to bring this into time constant form to write the equation, but to plot the graph you have to be careful. So to plot the graph, what should happen? So to plot the graph, I have to take a quantity called as MAO, magnitude of the origin. To get magnitude of the origin, I should ensure that none of the terms should contribute any magnitude at low frequencies. So I will take this as 1 plus 0.1 s, and here it is 1 plus, okay, 1 over 50 is 0.01. So 1 over 50 is 0.02. Sorry, 1 over 50 is 0.02. So this will be converted to 80 by 10 into 50. It is s plus 1. It is s into 1 plus 0.1 s and 1 plus 0.02 s. So what is the magnitude? This k in system gain will become 80 divided by 80 divided by 500. 80 divided by 500 would be 0.16. 0.16 s plus 1 s into 1 plus 0.1 s, 1 plus 0.02 s. So it will take a as 0.16 to start. That's it. So only MEAO will change. The phase equation, all these things, omega GC, omega PCs will never change with this, whether you take this or that equation. That will not change. Let us verify the same thing over here. So now let us try to find out what is omega GC and omega PC. So you can be careful here. Actually, of course, no need to find the value of phase at all different values of omega. Maybe you can predict what is the phase at 0 radian per second and infinite radian per second. At 0, you can see these are contributing 0, it is minus 90 degree. And at infinity, each one will contribute 90, 90, 90. So this is plus 90, minus 90, minus 20. This is already minus 20 is there. These two will go off, you'll end up with minus 180. So at any point of time, the phase will not be more negative than minus 180. Listen to me this carefully. At any point of frequency from 0 to infinity, the phase will never be more negative than minus 180. So it is reaching minus 180 only when omega is infinity. Only at the infinite frequency reaching minus 180 degree. So omega pc is it is infinite radian per second. That is the frequency at which this reaches minus 180 degree will happen only at infinite. So omega pc is infinite. If you put into your calcium, then try to find out omega pc, it will say can't solve. Okay, let me just show you what happens. Now, if you equate this to minus 180, see, I'm just typing it here. Minus 180 alpha equals minus 90 plus tan inverse of alpha a minus tan inverse of zero point 0.1 alpha a minus tan inverse of 0.02 alpha a. If I say shift cal, it says constant. Yeah, I equate it to minus 180. Let me see. It will not solve because it's going mad to calculate the value, because it happens at minus 180. It will just come as a message as can't solve. So there is no point in substitute. There is no point in giving any time for your calci to find what is this in such cases, because it is waste of time. We know that it is minus. So it's at infinite radian per second. Then it will simply waste of time. So you panic also. Can you see? It is now can't solve. So can't solve means it cannot identify if the value is infinite. It cannot find. So that's why it is showing can't solve. So now without actually solving this, without, you should not equate to minus 180 whenever this is omega pc expected is infinite. Of course, how to know that? We have to have some intuitive things. Okay, this we know trigonometrically. Whenever a tan inverse of infinity is 90 degree, you can see here this is 90, this is 90, this is 90. So it is minus plus will go off, then it is minus minus, then it is minus 180. That happens only when omega is infinity. So this is minus 180 only when it is infinite radian per second. So that your calculator cannot find. So this, without using calci, I am writing it as infinite radian per second. That's omega PC. How about omega GC? Omega GC I have to find here. So how do I do that? So let me use this calci. So it is now 0 alpha equals 20 log 80. I'm just using that without solving, without manipulating, without taking this. So plus 10 log of 1 plus alpha a square, close the parenthesis, minus 10 log, open the parenthesis, alpha a square plus, did I do square here? Yes, okay. Why did do this? So I have to make this, okay. I have to take this, the minus 20 log minus 20 log alpha a, this term, then minus 10 log alpha a square plus 10 square, sorry, 10 square, close the parenthesis, minus 10 log, open the parenthesis, alpha a square plus 50 square, close, shift cal. Now I'm looking for omega GC. So it will be a finite value. So from my MATLAB, I got it as 0.162. You can see I got this is the value what I got using MATLAB. So this is my, so this is 0.162 radian per second. See, now I have this as the omega GC. Omega PC is without using calci. So now I have to find what is the phase uh, omega GC, that is 0.162 radian per second. What I'll do here, so I will take out this sign. So I will take out this alpha equals minus 180 degree. I'm just removing it. So now I have to find the phase. I'm having the only the phase equation. So it's minus 90 plus tan inverse of alpha a minus tan inverse of 0.1 alpha minus tan inverse of 0.02 alpha a. So this is the phase equation I have. Using this equation, I will find what is the phase at 0.162. The phase is minus 81.91 degrees. So this is phase at omega GC. So then what is phase margin? Phase margin is 180 degree plus phase at omega GC, which is nothing but plus 180. It is now 98.08 degrees. Can you see here? This is 98 degree, which I calculated already. So this is 98 degrees. This is phase margin. What gain margin? So now gain margin is nothing but it is negative of the gain in dBs at omega equal to omega PC. When omega is equal, what is omega PC? Omega PC is infinite. So what is the slope you have? The final slope is minus 40 degree. So the slope is keep going like this. So if I can just go back and try to what is 20 log of is 20 log of 0.162. So it is minus 15 plus 20. So it will start from 4 dB. So somewhere here is a 0 dB. This is 4.2 dB is the starting point. It goes with a slope of this goes with a slope of minus 20, and then it becomes flat, and then becomes minus 20, then it is minus 40. So this is how the transfer function, how this is how the plot will go. So this is initially minus 20, then there is a 0, it will become flat, minus 20, minus 20. So ultimately it is going at minus 40 dB per decade. So when omega is infinity, where this has reached, so this is 0 dB, this is going keep going negative. So this may be minus infinite dB. This is infinity, this is minus infinity. So gain margin is infinite dB. Infinite dB. So that's what I predicted in the beginning itself. So this system is never oscillatory. If the existing gain is increased by whatever amount, the system will never become oscillatory. So that's what the meaning of this infinite GM. Okay. So let me take up another example where I'm just looking at something different. So where I can have there is no end for these type of problems. Maybe I can take up this problem. I can take this. So after this, we'll do one quadratic. Then the sixth one would be. But this is in this series. It is 6 GFS. I'll share this material with you people so that you can able to Okay, at the end of the by the end of the video, I'll simply glance through this so that you can have a note of that. So it is 50 into s plus 2 s plus 10 divided by s square into s plus 150 into n plus 1. You can see here. So this is the equation what I have. I'm writing it as 20 log of 50, and this is 10 log of omega square plus 2 square. It is this. It is 10 log of omega square plus 10 square minus of 40 log omega. It is 40 means it is square is there. Then minus of 10 log of omega square plus 150 square minus 10 log of omega square plus 1. This is in dBs. This is in absolute value. And this is a phase equation. You can see it is minus 180 degree plus of tan inverse of omega by 2 plus of tan inverse of omega by so and so. If you can see here, so what is that's what is interesting. So let me just make you people aware of this. So it is phase is equal to minus 180 degree plus tan inverse of omega by 2 plus tan inverse of omega by 10 minus tan inverse of omega by 150 minus tan inverse of omega. Correct? So now if I see this, so what is uh, for different values of omega, how does the phase looks like? This is 0, this is infinity. When it is 0, okay, all the omegas tan inverse of will going to contribute 0. You can see now it is minus 180 degree. So how about this? This is, what is this? So this is infinity. Now it is this is plus 90 plus 90 minus 90 minus 90. Actually these two will go off and you will still again when with minus 180. Okay. So it's minus 180 minus 180. Now if you take it as 0.1, so let me just take the phase equation here. So it is minus of 180 plus of tan inverse of uh, alpha a by 2 plus tan inverse of alpha a by 10 minus tan inverse of alpha a divided by 150 minus tan inverse of alpha a. So let me calculate for point 1. See for point 1, the phase angle is minus 182 degree. Calculate for point 5. Can you see it has become, for point 5 it has become minus 190. Can see initially the pole is at origin, sorry, at minus 1. Of course you have two poles at origin and one is minus 1 and you have two zeros at this point, and if you can see here these zeros will actually, so let me just calculate for a bit larger value of omega. At 1 you can see it is this. Calculate for 10, it is this. Maybe calculate for around 2, it is this. And calculate it around 3, is this. Calculate this it around, so when I calculate this for uh, 5, it is, you can see this is always going negative. So this is taking the uptrend, so this is keep going negative, this is keep going negative. So this is always negative. When this is always negative, can you see this has crossed this omega PC is coming out to be at, it has crossed it at 0 degree itself. It has crossed it at 0 degree itself. So this has crossed at 0 degree itself. Sorry, 0 radian per second. 0 radian per second. So it has crossed it at 0 radian per second. So now when it is at 0 radian per second, so this is what is omega PC. What is omega GC? Omega GC you can find. How do I find omega GC? So omega GC, so I will equate these two. I will equate these two 0 dB and try to find out. I'll take the magnitude equation, equate it to 0 degrees, sorry, 0 dBs and find what is omega GC. So that I'll do it. So meanwhile, you just try it over there. So let me show you these values in the MATLAB also. So let me just show you that in the next video. So what is the resultant of gain margin, phase margin of this equation, this transfer function in the next video. Thank you.